Assalamualaikum and good morning everyone. Today, we, Ezralina anak Puma Sangsa, Siti Nurulisa Sarah and I, Nur Ain Shahira, are pleased to present a comic titled Comic of Mathematics Issues in Malaysia. This comic highlights key challenge faced by elementary school students in learning mathematics. We will discuss the most common issues, analyze their impacts, and explore strategies to address them. So, this study aims to provide guidance for teachers to fostering a deeper mathematical understanding among students or pupils. Mathematics is a fundamental or a base subject in education, but many students in Malaysia struggle with it. So, this comic discusses common mathematical issues among elementary school students, backed by a journal article that offers insight or a solution. Our objective is to guide new teachers in improve student mathematical understanding while addressing this challenge effectively. We're gonna discuss the three main issues in mathematics learning among Malaysian students. So the three issues are, the first one is memorization over understanding. So students focus on memorizing formulas instead of understanding mathematical concepts. The second issue is limited understanding of statistical concepts. Students are struggle to interpret or analyze statistical data, and then the third issue is inconsistent assessment method. So there is a lack of standardization in assessing student geometric reasoning skill. So this challenge makes students harder to apply mathematics in real-world situations. The first issue is memorization over conceptual understanding. Many students prioritize memorization rather than truly understanding what is a mathematical concept. This approach creates a problem when they encounter unfamiliar questions that require reasoning, like in hot question. So, students perform poorly in problem-solving assessment, like international assessment such as TIMSS, PISA. The results show that Malaysian students struggle with conceptual application. Without a strong conceptual foundation, students may face difficulties in higher level mathematics and real life problem solving. So, what is the impact of memorization is learning? So, memorization can lead to many cons in education. First, it leads to poor performance in international assessments such as TIMSS and PISA that can found in article from Parmjit Singh. So, the second one is students struggle in solving real-world mathematical problems that in TIMSS result 2019 for 8th grade student, Malaysia ranked among the bottom 3 in problem-solving assessment, indicating a lack of conceptual understanding. To improve learning outcomes, students need to develop conceptual understanding rather than memorizations. So, how to overcome this problem? So, we as a teacher need to enhance conceptual learning in topic geometry to overcome this issue. So, we as a teacher need to propose inquiry-based learning. This encourages students to explore concepts in geometry topic through hands-on activities and discussion. And then, we as a teacher need to propose critical thinking and problem solving. These implement activities that can require logical reasoning to solve a problem. And the last one is real life application. So teacher need to relate mathematical concept to everyday situation to enhance understanding in mathematical. So by applying these strategies, teacher can help student to build a strong mathematical foundation or base to improve their problem solving skills.
The third issue is that students have limited understanding of statistical concept, where many students misunderstood the use of mean, median, or mode appropriately. So, in this problem, students will be hard to apply statistical concept in their real life and justify their reasoning. So, this involves when the student fail to connect data with visual representation like bar chart, pie chart, and also histogram. When they misread graph, they will make incorrect conclusion, and they will also, when given a graph without numbers, they struggle to estimate the tendency values. So these are the few questions that were used as an instrument to assess the misconception that students are facing. So they will be given a histogram, and they have to answer the question accordingly by the histogram to find the mean and explanation, to find the mode and explanation, to find the median and explanation, and the last one, which measure of tendency that is most suitable to be represent the score obtained by the student and the explanation. So the first table reveals the misconception of students regarding mean for that question. So there are only 37.62% of students answer the question correctly, and the rest have a misconception about the mean. So actually most of the student, number of student, 44 student, have misconception that finding the mean of heights of bar and dividing by number of data on the horizontal axis. So it is incorrect actually, because simply by arranging the heights of bar does not consider the number of occurrences in each category. So the correct way to find the mean is to multiply each of the category on the horizontal axis by its corresponding bar heights, which is frequency. And the second one, we have to add up all the values from step 1. And the last one, we have to divide the total by the number of categories by the total of frequency if it represents the numerical data. So the table 2 reveals the misconception of students regarding the mode for question 3B1 and also 3B2. So there are 73.79% students answer it correctly, and the rest have misconception. So some of the misconception that they are facing, they think that mode is referred to as a peak, as the highest point on the curve and as the top of the curve. So the second is mode is the numbers that appears the most in the score and irrelevant, and there are also 46 students that have no attempt to answer that question. So the table 3 reveals the misconception of students regarding the medians. So there are only 9.22% of students who answer it correctly, and the rest of it have misconception about the medians. So there are students who finding the median of frequency of the data values, and there are also students who finding the median of the values on the horizontal axis, and there are also students who dividing the numbers of data on the horizontal axis by 2 or 1 to find the medians, which all of it are incorrect, because when I try to find the median, the answer is 8 for that histogram. So there are 163 students who have irrelevant answer and 94 students who have no attempt to answer that question. So for the last question, 28 students, which is 6.80%, knew that median was the most suitable measure of central tendency to represent the data, which is correct, but they did not know how to explain the answer. So the finding in this question confirmed that the argument put forth by Zawojeski and Saujesnesny 2000, which is stated that students face difficulty in choosing the appropriate measure of the central tendency to best represent data. So here are some of the way to overcome this issue by using the real life application and hands-on activities to help students to understand when and why to use each measures. The second one, to revise a question that reflects teams and PISA style so that students would be ready. The third one, foster a growth mindset and use gamified learning approach. And the last one, to integrate online learning.
Now, I will be discussing the inconsistency in how geometric reasoning is assessed in Malaysian primary schools. Our current methods focus more on calculations rather than true geometric understanding. So, why is this important? Well, in Malaysian primary schools, geometry assessments primarily test students on calculations, such as finding the area and perimeter, rather than evaluating their ability to visualize shapes, transformations, and spatial relationships. On the other hand, teams and PISA take a different approach, emphasizing spatial reasoning and real-world problem solving. So the objective of this presentation is to highlight these gaps and propose ways to improve our assessment methods to align better with international standards. Malaysian primary school assessments. So, in Malaysia, geometry assessments heavily rely on formula-based problem solving. Students are taught to memorize and apply formulas, such as those for area and perimeter, rather than develop a deeper understanding of geometric relationships. One of the main issues is the lack of standardized rubrics to measure geometric reasoning. This results in inconsistent evaluation methods where students' true understanding of geometry may not be accurately assessed. In contrast, teams and PISA assess students' ability to reason geometrically rather than just recall formulas. Teams focuses on analyzing and justifying geometric relationships. Students must explain why certain properties hold rather than just solve for numerical answers. PISA challenges students to apply geometric concepts in unfamiliar real-world contexts. This requires logical thinking and the ability to connect geometry ideas beyond the textbook exercises. So, what are the key issues with our current approach? First, there is an over-reliance on formula recall, where students are only expected to complete answers without truly understanding the reasoning behind them. The second one, problem-solving and reasoning-based questions are rarely included in exams, making it difficult to gauge students' ability to apply their knowledge. And the last one is, due to the lack of structure framework, assessments fail to measure deeper geometric thinking, leaving gaps in students' learning experiences. So these issues contribute to Malaysian students struggling in international assessments like TIMSS and PISA. To support what I said just now, I refer to a study that examines one year levels of geometric thinking among Malaysian students and discusses strategies to improve assessment. The study found that Malaysian exams focus on formula recall. The article highlights how most assessments emphasize calculation over reasoning. The second one, TIMSS and PISA emphasize spatial reasoning. The study shows that Malaysian students struggle with analyzing geometric relationships because they are not trained in reasoning-based assessments. The third one, need for better assessment rubrics. The article suggests that developing structured rubrics would help in accurately measuring students' understanding. And the last one is alternative assessments for teachers. The study recommends incorporating open-ended and exploratory tasks to enhance students' thinking. So this research supports the idea that our current assessment methods need improvement and the suggested solutions align with international best practices. So, to address these issues, we need to improve the way we assess geometric reasoning in four key areas. The first one, develop standardized rubrics for geometric reasoning. We should create assessment rubrics aligned with Van Hill's levels of geometric thinking, which focus on visualization, logical deduction, and spatial reasoning. This will help teachers assess students more consistently and accurately. The second one, incorporate teams precise style questions in school exams. Instead of just asking students to calculate, we should introduce students to questions that require analysis, justification, and real-world applications of geometry. The third one, train teachers to use alternative assessments. Teachers need training on designing open-ended and exploratory geometric problems. Activities such as investigating geometric patterns, using hands-on transformations, and justifying properties in written form can help develop reasoning skills. Other than that, digital tools like GeoGebra or interactive simulations can also enhance learning. And the last one is implement formative assessments, continuous improvement. Instead of relying only on exams, ongoing diagnostic tests should be used to track students' reasoning skills. Teachers should provide constructive feedback, not just correct or incorrect answers. Collaborative problem-solving activities such as group discussions and also peer evaluations can encourage deeper understanding. So by implementing these solutions, we can improve students' ability to think geometrically and align our assessments with international standards. So that's all from our group. Thank you.